Hello everyone. In the beginning of the class, please pause the video and review the following problems first. After you finish doing the following problems, you can continue the video and I will show you all the solutions in detail. Let's work together for these problems. First problem, x squared plus 3x plus minus 10 over x squared minus 6x plus a times x squared minus 7x plus 12 over x squared plus 6x plus 5. When we try to multiply rational expressions, we first of all factor each numerator and denominator. When we try to multiply two rational expressions, we first of all try to factor each numerator and denominator. For the first numerator, it's a trinomial with no leading coefficient, so we draw two parentheses, write x on each parenthesis. Next, we try to find two numbers. When we multiply, we get negative 10. When we add, we get positive 3. For negative 10, we can try 2 and 5. Since we want to get positive 3 in the middle, we make negative 2 and positive 5. Negative 2 times negative 2 times positive 5 is negative 10. And when we add negative 2 plus positive 5 is positive 3. So these two numbers works. Put it in the parentheses. Negative 2 and positive 5. On the denominator, same thing, it's a trinomial. And there's no leading coefficient. We can draw two parentheses, put x on each parenthesis. Next, we try to find two numbers. Like when we multiply, we get a. When we add, we get negative 6. For number a, we can try 2 and 4. Since we took a negative 6 in the middle, we use negative 2 and negative 4. Negative 2 plus negative 4 is negative 6. Negative 2 times negative 4 is positive a. So these two numbers works. Put it in the parentheses. For the second fraction, do the same thing. Factor each numerator and denominator. If we factor the first numerator, this is a trinomial with no leading coefficient. So we draw two parentheses, put x on each parenthesis. Next, we try to find two numbers. When we multiply, we get 12. When we add, we get negative 7. We can try to use 3 and 4. Since we don't get negative 7 in the middle, negative 3 times negative 4 is negative 3 plus negative 4 is negative 7. And when we multiply, negative 3 times negative 4 is positive 12. So these two numbers works. On the denominator, same thing. This is a trinomial with no leading coefficient. We write x on each parenthesis. Then we try to find two numbers. When we multiply, we get 5. When we add, we get 6. We can try 1 and 5. Since we get positive 6 in the middle, we use positive 1 and positive 5. Positive 1 plus positive 5 is positive 6. Positive 1 times positive 5 is 5. So these two numbers works. Put both numbers in the parentheses. Then we try to cancel the common factors from top and the bottom. Next, cancel common factors from top and the bottom. I can first of all cancel x minus 2 from top and the bottom. I can cancel x plus 5 from top and the bottom. I can cancel x minus 4 from top and the bottom. What's left is x minus 3 and x plus 1. That's the final answer. What's left is x minus 3 on the top, x plus 1 on the bottom. That's the final answer. Next, x squared minus x minus 12 over 2x cubed minus 18x divided by x squared minus 16 over 5x squared plus 20x. When we are doing division, when we divide two fractions, we keep the first fraction the same. Keep the first fraction the same. Change division to multiplication. Then we flip the second fraction over. When we are doing division, keep first fraction the same. Change division to multiplication, and flip the second fraction over. Next, we try to factor each numerator and denominator. If we factor the first numerator, x squared minus x minus 12, we try to find two numbers. Like when we multiply, we get negative 12. When we add, we get negative 1. If there's no coefficient, we assume coefficient is 1. So we try to find two numbers. Like when we multiply, we get negative 12. When we add, we get negative 1. We can try to use 3 and 4. Since we try to get negative 1 in the middle, we can use 3 and 4. And since we try to get negative 1, we use positive 1 and negative 4. When we multiply, we get negative 12. When we add, we get negative 1 in the middle. So these two numbers works. X plus 3, x minus 4 on the numerator. Put x on each parentheses, and then these two numbers works. Positive 3, negative 4. Next, let's factor the denominator. For the denominator, we have 2x to the power 3 minus 18x. We can first of all pull out the common factor. I can first of all pull out the common factor, which is 2x. 2 is the largest number that divides both 2 and 18. X is the common variable. Lowest power is power 1. So 2x is the common factor. From the first factor, if I pull out 2, there's no 2 left. If I pull out x, there are 3x multiplied together. X to the power 3 means there are 3x multiplied together. If we pull out one of an x, we have 2 more x left inside. Second term, 18 divided by 2 is 9. There's only one x. If I pull out x, then there's no x left. X squared is a perfect square. X squared is a perfect square. Number 9 is also a perfect square. 3 times 3 is 9. Since they are both perfect squares, we can use the formula that a squared minus b squared equal to a plus b times a minus b. We can use this formula to factor. So x here represents a, 3 represents b. We have x plus 3, x minus 3. Bring 2x over. That's the factor form of the denominator here. So put this on the denominator, we have 2x times x plus 3, x minus 3. That's the denominator. Second numerator. For the second numerator, 5x squared plus 20x, I can try to take out common factors. For 5 and 20, the greatest common factor is 5. That's the largest number that divides both 5 and 20. Common letter is x. Lowest power is power 1. If I pull out 5x, for the first time, if I pull out 5, there's no 5 left. If I pull out one of an x, there's one more x left. First term, there are 2x multiplied together. If I pull out one of an x, another x left here. Plus, the second term, 20 divided by 5 is 4. There's only one x. If I pull out x, then there's no x left. On the denominator, s squared minus 16. S squared itself is a perfect square. 16 is a perfect square. 4 times 4 is 16. So 16 can be rewritten as 4 squared. If we use the formula here again, we have x plus 4 times x minus 4. That's the denominator. S plus 4 times s minus 4. Then we can cancel common factors. I can cancel x plus 3 from top and the bottom. I can cancel x minus 4 from top and bottom. I can cancel x plus 4 from top and bottom. I can cancel 1 over x. I can cancel x from top and bottom. So what's left on the top? What's left on the top is number 5. Everything else can cancel. What's left is number 5 on the top. On the bottom, what's left is number 2 and x minus 3. So the final answer is 2 times x minus 3 on the denominator, 5 on the top, and 2 times x minus 3 on the denominator. That's the final answer. Next problem, x minus 15 over s squared minus 2x minus 3 plus x over x minus 3. In order to add two rational expressions, we need to find the least common denominator. So in order to find the least common denominator, we need to factor each denominator first. So let's factor each denominator first. If I factor the first denominator, this is a trinomial with no leading coefficient. Put x on each parenthesis. Then try to find two numbers. When we multiply, we get negative 3. When we add, we get negative 2. We can try to use number 1 and number 3. Since we don't get negative 2 in the middle, we can use positive 1, negative 3. When we add, we get negative 2 in the middle. So we use positive 1 and negative 3. Second fraction, the denominator cannot be factored. X minus 3 cannot be factored. X minus 3 cannot be factored, so we leave it the way it is. This denominator cannot be factored, so we leave it the way it is. Next, we find the least common denominator. Least common denominator must include every factors. We must include x plus 1, x minus 3. But we have x minus 3 already, so only write that once. We have x minus 3 already, only write that once. This is the least common denominator. Next, we try to rewrite every fraction over the least common denominator. First fraction, the denominator looks exactly the same as LCD, so don't make any change. Second fraction, if we compare the denominator with LCD, we can see that what's missing is x plus 1. What's missing is x plus 1. So we need to multiply the top and the bottom by x plus 1. If we compare the denominator with the LCD, what's missing is x plus 1. So we multiply the missing factor to the denominator. If we multiply the missing factor to the bottom, we need to multiply the same thing to the top. Then, after we multiply out, we can see that the denominator looks exactly the same. Denominator will be x plus 1 times x minus 3. After we multiply out, we can see that both denominator looks exactly the same. Then we can put the numerator together. Once we make denominator the same, we can put the numerator together. Then simplify the numerator. For the numerator, I can try to distribute first, then combine like terms. If I distribute x, I have x squared plus x. Denominator stays the same. Now let's combine like term and factor the numerator. Numerator is x minus 15 plus x squared plus x. If I combine like term, I can put this in descending order, which means the term with higher power comes first. That's x squared, x plus x. 1x plus 1x is 2x. X plus x is 2x minus 15. Then we try to factor the numerator. This is a trinomial. With no leading coefficient, so I can put x on each parenthesis. Next, find two numbers. Let multiply to be negative 15, add to be positive 2. For number 15, we can try 3 and 5. Since we have to get positive 2 in the middle, we can use negative 3, positive 5. When we multiply, we get negative 15. When we add, we get positive 2. So these two numbers works. Put both numbers in the parentheses. -3, +5. That's the factor form of the numerator. That's the factor form of the numerator. So the numerator is x minus 3 times x plus 5. Denominator is x plus 1 times x minus 3. Then here we can cancel the common factors. We can cancel x minus 3 from top and the bottom. What's left is s plus 5 over s plus 1. That's the final answer. S plus 5 over s plus 1. That's the final answer. Next, x squared over x over s squared minus 9. S over s squared minus 9 plus 4 over s squared minus 2x minus 15. When we try to add or subtract two rational expressions, we need to first of all find the least common denominator. In order to find the least common denominator, we need to factor both fractions. Factor both denominators, then we can find the least common denominator. First denominator is s squared minus 9. S squared is a perfect square. Number 9 is also a perfect square. 3 times 3 is 9. So s squared minus 9 can be rewritten as s squared minus 3 squared. Then we use the formula for difference of perfect square. We have x plus 3 times x minus 3. That's the factor form of the denominator. X plus 3, x minus 3. For the second denominator, for the second fraction, this denominator is a trinomial with no leading coefficient. So you can draw two parentheses, put x on the parentheses, put x on each parentheses. Next, try to find two numbers that when we multiply, we get -15. When we add, we get -2. We can try to use 3 and 5. Since we try to get -2 in the middle, we can use +3 and -5. When we multiply, we get -15. When we add, we get -2. So put it in the middle, +3, -5. Next, we try to find the least common denominator. Least common denominator must include every factor on denominator. So we must include x plus 3, x minus 3. We have s plus 3 already, so don't repeat. We have s plus 3 already, but we don't have s minus 5. Put it here. That's the least common denominator. Now, compare each fraction. Try to write each fraction over the least common denominator. Let's compare the first fraction with an LCD. If we compare the denominator with LCD, we can see that what's missing is x minus 5. So in order to make denominator looks like an LCD, we multiply the bottom by x minus 5. Then do the same thing to the top. Multiply the same thing to the top. For the second fraction, if we compare the denominator with LCD, we can see that what's missing is s minus 3. If we compare the denominator with LCD, we can see that what's missing is s minus 3. So multiply the missing factor to the denominator. Then after we multiply, we get the same denominator as LCD. Then whatever we multiply to the bottom, multiply the same thing to the top. Then after we multiply out, both denominator will be exactly the same. So write it only once. X plus 3, x minus 3, s minus 5. Then put both numerator together. Write denominator only once. Write the common denominator once. Then put the numerator together. Write the common denominator once. Put the numerator together. We have x times x minus 5 plus 4 times x minus 3. Then we try to simplify the numerator. Keep denominator the same. Then keep denominator the same. Simplify the numerator. Keep denominator the same. Simplify the numerator. Numerator is x times x minus 5 plus 4 times x minus 3. We can distribute x first. We get x squared minus 5x. Distribute 4 into the second parenthesis. We have 4x minus 12. Then combine like terms. Combine like terms. We have x squared minus 1x minus 12. Then factor. This is a trinomial with no leading coefficient. Put x on each parenthesis. Then try to find two numbers. When we multiply, we get negative 12. When we add, we get negative 1. We can try to use 3 and 4. Since we try to get negative 1 in the middle, we can use positive 3, negative 4. Then when we multiply, we get negative 12. When we add, we get negative 1. So put these two numbers in the middle. Positive 3 minus 4. That's the simplified form of the numerator. That's the simplified form of the numerator. Put it here. X plus 3 times x minus 4. Then we can cancel the common factor. Cancel the common factor. Cancel x plus 3. Cancel the common factor. The final answer is x minus 4 on the top, x minus 3 times s minus 5 on the bottom. That's the final answer. Next, solve the equation 5 over s plus 1 equal to 3 times x plus 3. Solve the equation. When we have two fractions, when we have two single fractions on each side of the equation, we can cross multiply. It's a special case. When we have two single fractions on both sides of the equation, we can try to cross multiply. If I cross multiply, I have 5 times x plus 3 equal to 3 times s plus 1. If I cross multiply, I have 5 times x plus 3 equal to 3 times s plus 1. Then solve the equation. Solve the equation for x. I can distribute 5 first. If I distribute 5, I get 5x plus 15. If I distribute 3 on the other side, I have 3x plus 3. Then solve the equation for x. I can first of all subtract 3x from both sides. 5x minus 3x is 2x. On the other side, positive 3x and negative 3x can cancel. We get number 3 by itself. Then solve for x. We need to eliminate 15 first. Subtract 15 from both sides. On the left side, positive negative 15 can cancel. We get 2x by itself. On the right side, we try to combine like terms. Positive 3 plus negative 15. Positive 3 plus negative 15 is negative 12. In order to get s by itself, we divide both sides by 2. In order to get s by itself, we divide both sides by 2. On the left side, number 2 on the top and the bottom can cancel. We get s by itself. On the right side, negative 12 divided by 2. Negative 12 divided by 2 is negative 6. Negative number divided by positive number is negative. 12 divided by 6. 12 divided by 2 is 6. Now, this is a rational equation. For a rational equation, we must check this answer doesn't make the denominator equal to 0. If this answer makes the denominator equal to 0, we must reject this answer. Let's plug in negative 6. Negative 6 on the first denominator. Negative 6 plus 1 is not 0. That's okay. Negative 6 plus 1 is not 0. That's okay. In the second denominator, negative 6 plus 3 is not 0. That's okay. So this answer is valid. This answer is valid. Since it doesn't make denominator 0, this answer is valid. So the answer is s equal to negative 6. Next. Next. 1 over x minus 3 equal to number 8 over x squared minus 9. 1 over x minus 3 equal to number 8 over x squared minus 9. When we have single fractions on both sides, we can try to cross multiply. We can try to cross multiply. If we cross multiply, we have 1 times x squared minus 9 equal to 8 times x minus 3. If we cross multiply, we have 1 times x squared minus 9 equal to 8 times x minus 3. Then we can try to solve this equation for x. I can first of all distribute number 1, which is x squared minus 9. Distribute a, we have ax minus 24. Next, we try to bring everything together. This is a second degree equation. Try to move everything to one side, making the other side 0. I can first of all try to combine the constants first, combine the numbers first. If I add 24 to both sides, on the right side, positive 24, negative 24 will be cancelled. We have ax left. On the left side, x squared stays the same. Negative 9 plus 24. Combine like terms. Negative 9 plus positive 24 is positive 15. Next, we try to move ax over. Try to eliminate ax from right side. So I can subtract ax from both sides. On the right side, positive ax and negative ax get cancelled. It gets 0 by itself. On the left side, we try to combine like terms here, but there are no like terms to be combined. We try to combine like terms here, but there are no like terms to be combined. If there are no like terms can be combined, put this in descending order. If there are no like terms can be combined, put this in descending order. Descending order means the term with higher power come first. Descending order means the term with higher power come first. Then I can try to factor. I can try to solve this equation by factoring. This is a trinomial. So put x on each parenthesis. Try to factor 15. Find two numbers that multiply to 15, add to be negative a. We try to find two numbers that when we add, we get positive 15. When we add, we get negative a. We can try to use negative 3 and negative 5. When we multiply, get positive 15. When we add, we get negative a. So these two numbers works. Put them in both parentheses. Then once I make the product of two factors equal to 0, once I make the product of two functions equal to 0, I set each of them equal to 0. Set each of them equal to 0. We can set x minus 3 equal to 0. And we can set x minus 5 equal to 0. For the first equation, we can add 3 to both sides. We get s equal to 3. For the second equation, we can add 5 to both sides. If we add 5 to both sides, on the left side, we get s by itself. On the right side, 0 plus 5 is 5. So here we get two solutions, 3 and 5. Let's check. Does this two number make the denominator equal to 0? Let's check 3 first. If I plug in 3 into the first denominator, 3 minus 3 denominator is 0. That's invalid. This is invalid. If solution make denominator 0, this solution is invalid. So this answer must be rejected. How about 5? If I plug in 5 here, 5 minus 3 is not 0. How about the other one? 5 squared is 25. 5 squared means 5 times 5, which is 25. 25 minus 9 is 16, which is not 0. So this answer is valid. 3 is rejected. Number 4 is valid. The solution is x equal to 5. The solution is x equal to 5. Now, for problem number 6, we can also solve it in a different way. For problem number 6, we can also solve it in a different way. If the denominator is too complicated, when we cross multiply, sometimes you may get some equation that looks messier. If the denominator is very complicated, there's a second way to solve it. Let me show you a different way to solve number 6. If the denominator is factorable, there may be a second way to solve it. Let me show you here. For number 6, let me show you a second way to solve this problem. When the denominator is factorable, we can try to factor the denominator first. Find a common denominator. Observe the denominator. We have s squared minus 9. This denominator is factorable. S squared is x squared. Number 9 is 3 squared. 3 times 3 is 9. That's the difference of perfect squares. If I use the formula, I have x plus 3 times x minus 3. So, factor the denominator first. Then we can try to find the least common denominator. Factor the denominator first, then try to find the least common denominator. The least common denominator must include all factors on the denominator. For the first denominator is x minus 3. Second denominator, we have x plus 3. And x minus 3, we have it already. We have x minus 3 already, so don't repeat. Write everything exactly once. That's the least common denominator. Next, we try to put every fraction over the least common denominator. For the first fraction, we have x minus 3. The denominator is x minus 3. If we compare the denominator with LCD, we can see that what's missing is x plus 3. So I multiply the missing factor to the top and the bottom. After multiply, the denominator will look exactly the same as LCD. Next, on the other side, we have a over x plus 3, x minus 3. If we observe the denominator, we can see that this denominator looks exactly the same as LCD. So if the denominator looks exactly the same as LCD, we don't make any change, leave it the way it is. Then for equations, especially for rational equations, if the denominator looks exactly the same, we can drop the common denominator. For rational equations, if the denominator of every term looks exactly the same, we can drop the common denominators. So what's left is 1 times x plus 3 equal to a. After we multiply out, both denominators look exactly the same. And for rational equation, if the denominator of every term looks exactly the same, we can drop the common denominator. If we drop the common denominator, that's what's left. Then solve an equation for x. 1 times x is x. 1 times 3 is 3. In order to get x by itself, we can subtract 3 from both sides. So on the left side, positive 3, negative 3 can cancel. We get x by itself. On the right side, a minus 3 is 5. Let's check. Make sure this answer doesn't make LCD equal to 0. If I plug in 5 here, 5 minus 3 is not 0. 5 plus 3 is also not 0. So this answer is valid. The answer is x minus 5. So here, that's a different way to solve number 6. That's a different way to solve number 6. The answer in both problems is exactly the same. We get exactly the same solution in both problems. That's a different way to solve number 6. Number 7. 4 over s minus 4 minus 3 over x minus 3 equal to 1. So first step, when we have a rational equation, we try to find the least common denominator first. If an equation contains a denominator, first step, factor each denominator. Write every term as a fraction. Factor each denominator. First denominator, x minus 4. This denominator cannot be factored. It's not factorable. Second denominator, we have x minus 3. It's also not factorable. Number 1 is a whole number. We put it over 1. Not as a fraction, put it over 1. Next, we try to find the least common denominator. Least common denominator must include everything. It must include x minus 4, every factor on the denominator. It must include x minus 4, x minus 3, and number 1. Usually put number 1 in the front. But for any polynomial, if the coefficient is 1, we don't write 1. We put this number 1 in the front. But for any polynomial, if the coefficient is 1, we don't write 1. So 1 times x minus 3, x minus 4 is the same as x minus 3 times x minus 4. This 1 is not necessary. That's the least common denominator. Now, next, we try to rewrite every fraction over the least common denominator. First fraction, 4 over s minus 4. If we compare denominator with LCD, what's missing is s minus 3. What's missing is s minus 3. So multiply x minus 3 to the top and the bottom. After we multiply, we can see that the denominator looks exactly the same as LCD. Second fraction, we have 3 over x minus 3. If we compare denominator with LCD, we can see that what's missing is s minus 4. So multiply the missing factor from the top and the bottom. Then, if we multiply, the denominator will be exactly the same as LCD. Last term is 1 over 1. If we compare denominator with LCD, what's missing is s minus 4, x minus 3. So I multiply both factors to the denominator. X minus 4, x minus 3. Multiply both factors to the denominator. And do the same thing to the top. X minus 4, x minus 3. Then, after we multiply everything out, every denominator will be exactly the same. After we multiply everything out, we can see that every denominator looks exactly the same. And for any rational equation, if denominator of every term looks exactly the same, we can drop the common denominator. So after we drop the common denominator, we have 4 times x minus 3 minus 3 times s minus 4 equal to 1 times x minus 4, x minus 3. After we multiply, the denominator looks exactly the same. And for any rational equations, if the denominator looks exactly the same, we can drop the common denominator, and that's what's left. Then simplify this equation, simplify this polynomial. Simplify the polynomial on both sides. First of all, if the coefficient is 1, we don't need to write 1. We can eliminate this 1 here first. Then distribute. On the left side, if I distribute 4, we have 4x minus 12. If I distribute negative 3, I have negative 3x plus 12. On the right side, there are 2 parentheses. When I distribute, I take every term in the first parenthesis, multiply to every term in the second parenthesis. Every term in the first parenthesis, multiply to every term in the second parenthesis. We have s squared minus 3x, distribute 4. We have minus 4x plus 12. Next, we try to combine like terms. Combine like terms. 3x minus 4x is 1x. Negative 12 and positive 12 get cancelled. Negative 12 and positive 12 get cancelled. on the other side, we have x squared, -3, -4. When I combine like -3x, -4x, when I combine like terms, -3 plus -4 is -7 plus 12. Next, this is a second degree equation. This is a second degree equation. We try to make one side of an equation 0 first, then solve an equation by factoring. This is a second degree equation. You can try to make one side of an equation 0 first, then solve an equation by factoring. I can subtract 1x from both sides. Then on the left side, 1x and -1x can cancel, we get 0 by itself. On the right side, x squared stays the same. If I combine like term here, -7x plus -1x, I combine like term, follow addition rule. -7 plus -1 is -8. So you get -8x plus 12. Then, this is a trinomial with no leading coefficients. This is trinomial with no leading coefficient. We can draw two parentheses, put x on each parentheses, then we try to find two numbers that when we multiply, we get 12. When we add, we get -8. Try to find two numbers. When we multiply, we get 12. When we add, we get -8. We can try to use 2 and 6. Since we try to get -8 in the middle, we can use -2 and -6. When we add, we get -8. When we multiply, we get +12. So these two numbers works. S minus 2, x minus 6. Then since two functions multiply to be 0, we set each of them equal to 0. S minus 2 equal to 0, s minus 6 equal to 0. Set each of them equal to 0. Solve each of them individually. For the first equation, I can add 2 to both sides. S equal to 2. For the second equation, add 6 to both sides. +6, -6 cancel. We get s equal to +6. Now check the answer. Make sure this number doesn't make denominator equal to 0. If I plug in 2, 2 minus 4 is not 0. 2 minus 3 is also not 0. So number 2 is valid. This number 2 is valid. How about 6? Is 6 valid? Let's plug in 6. If I plug in 6 here, 6 minus 4 is not 0. 6 minus 3 is also not 0. So 6 is also valid. So for this equation, we have two solutions. S equal to 2 or s equal to 6. There are two solutions. S equal to 2 or s equal to 6. There are two solutions. Next. Three over s squared minus 16 plus 1 over 2x plus a equal to 0. So this is a rational equation. We first of all try to factor each denominator, find the least common denominator. First of all, factor each denominator and find the least common denominator. First denominator, s squared minus 16. S squared minus 16. S squared itself is a perfect square. 16 is also perfect square. 16 is 4 times 4 is 16. 16 is also perfect square. So we have a difference of two perfect squares. We can use the formula. S plus 4 times s minus 4. So that's the denominator. S plus 4, s minus 4. That's the first denominator. Also, factor the second denominator. For the second denominator, I can pull out number 2. 2 is a common factor. I can pull out 2. If I pull out 2, I have x minus 4. Pull out 2, there's x left. For the second term, a divided by 2 is 4. I can write 0 as 0 over 1. For any whole number, I can put a whole number over 1. Next, find the least common denominator. Next, we can try to find the least common denominator. Find the least common denominator. least common denominator must include all factors. X, we must have x plus 4, x minus 4. We have x plus 4 already, don't repeat it. Now the whole numbers, we have 2 and 1. For number 2 and number 1, the least common multiple is 2. For number 2 and number 1, the least common multiple is 2. So this is the least common denominator. Now, next, try to write every fraction over the least common denominator. For the first fraction, we have 3 over x plus 4 times s minus 4. If you compare the denominator with LCD, what's missing is number 2. If you compare the denominator with LCD, what's missing is number 2. So we multiply 2 to the top and the bottom. After we multiply 2 on the denominator, it looks exactly the same as LCD. Second fraction, we have 2 times x plus 4. If we compare the denominator with LCD, we can see that what's missing is s minus 4. So we multiply s minus 4 to the top and the bottom. After we multiply, the denominator looks exactly the same as LCD. On the right side, the denominator is 1. If we compare the denominator with LCD, we can see that everything is missing. So multiply denominator by the missing factors. 2 times x plus 4, x minus 4. Multiply the same thing to the top. S plus 4, s minus 4. Then, after we multiply, every denominator will looks exactly the same as LCD. After we multiply, every denominator will look exactly the same as LCD. Then I can drop the common denominators. For a rational equation, if every denominator looks exactly the same, we can drop the common denominators. So for the first fraction, we have 3 times 2 plus 1 times x minus 4 equal to 0 times 2 times x plus 4, s minus 4. Then simplify. First term, 3 times 2 is 6. Second term, distribute 1, we have 1x minus 4. 1 times x is 1x. 1 times 4 is 4. On the right side, 0 times everything is 0. On the right side, 0 times everything is 0. Then we can combine like terms. We can combine like terms here. Positive 6 and negative 4. Positive 6 plus negative 4 is positive 2. Positive 6 plus negative 4 is positive 2. In order to get s by itself, I can subtract 2 from both sides. So the final answer is s equal to negative 2. Let's check the answer. Let's make sure this answer is valid. If I substitute negative 2 into the LCD, first factor here, negative 2 plus 4. Negative 2 plus 4 is not 0. Negative 2 minus 4 is also not 0. Since negative 2 doesn't make denominator 0, this answer is valid. Since negative 2 doesn't make denominator 0, this answer is valid. So the answer is s equal to negative 2. Next, x over 5x plus 5 equal to 1 over x plus 2 plus x squared plus 3x plus 2. So for a rational equation, we first of all factor each denominator, find the least common denominator. We first of all factor each denominator and find the least common denominator. First denominator, 5x plus 5. I can pull out number 5. And that's the least common multiple for both numbers. If I pull out 5, for first term, if I pull out 5, there's x left. For the second term, 5 divided by 5 is 1. Second denominator, second fraction. For the second fraction, the denominator is not factorable. I leave it the way it is. For the third fraction, this is a trinomial. The denominator is a trinomial with no leading coefficients. I can put x on each parenthesis, then find two numbers. When we multiply, we get 2. When we add, we get 3. Try to find two numbers. When we multiply, we get 2. When we add, we get 3. The only possibility here is 1 and 2. Positive 1, positive 2. Positive 1 times positive 2 is 2. Positive 1 plus positive 2 is positive 3. So these two numbers works. These two numbers works. I can put that in the parentheses. Positive 1, positive 2. Next, we try to find the least common denominator. Least common denominator must include every factors on the bottom. So first of all, we have number 5 on the bottom. We have x plus 1 on the bottom. We have x plus 2 on the bottom. And x plus 1, we have it already here. We also have x plus 2 already. So don't write everything exactly once. Don't repeat. That's the least common denominator. That's the least common denominator. Next, try to write every fraction. Try to write every fraction over the least common denominator. If we compare first denominator with LCD, what's missing is x plus 2. If we compare the first denominator with LCD, what's missing is x plus 2. So we multiply the missing factor to the top and the bottom. After we multiply, the denominator looks exactly the same as LCD. Second term, 1 over s plus 2. If we compare the denominator with LCD, what's missing is number 5 and s plus 1. What's missing is number 5 and s plus 1. Multiply the missing factor to the top and the bottom. Third term, 1 over s plus 1, s plus 2. If we compare the denominator with LCD, what's missing is number 5. So we multiply number 5 to the top and the bottom. Now here we can see that after we multiply each fraction, the denominator, all denominator will look exactly the same as LCD. All denominator will look exactly the same as LCD. Then, for any rational expression, for any rational equation, if the denominator of every term looks exactly the same, we can drop the common denominator. Drop the common denominator, we have x times s plus 2 equal to 1 times 5 times x plus 1 plus 1 times 5. If we drop the denominator, that's what we get here. If we drop the common denominator, that's what we get here. Next, let's multiply out. Distribute x, we have x squared plus 2x. X times x is x squared. X times 2 is 2x. 1 times 5 is 5. Distribute 5 into the parentheses. 1 times 5 is 5. Distribute 5 into the parentheses. 5 times x is 5x. 5 times 1 is 5. Last term, 1 times 5 is 5. Then we can combine like terms. If we combine like terms, 5 plus 5 is 10. This is a second degree equation. We try to bring everything to one side. Make one side of the equation 0. Then solve the equation by factoring. I can first of all subtract 5x from both sides. On the left side, on the right side here, positive 5s and negative 5s can cancel. We have number 10 left. On the left side, we have s squared positive 2x minus 5s. If we combine like terms, we can add the coefficient. Positive 2 plus negative 5. Positive 2 plus negative 5 is negative 3. X stays the same. Next, we can bring number 10 over. Subtract 10 from both sides. On the right side, positive 10, negative can cancel. We get 0 by itself. On the left side, we try to combine like term, but nothing can be combined. If nothing can be combined, keep every term, write in descending order. Keep every term, write in descending order, which means the term of higher power comes first. We have x squared minus 3x minus 10. Then we can try to factor this by factoring. This is a trinomial with no leading coefficient. We try to find two numbers. When we multiply, we get 10. We get negative 10. When we add, we get negative 3. We try to find two numbers. When we add, we get negative 10. So when we multiply, we get negative 10. When we add, we get negative 3. Let's try 2 and 5 first. Since we try to get negative 3 in the middle, we can try positive 2, negative 5. Then when we multiply, we get negative 10. When we add, we get negative 3. So these two numbers work. We can use x plus 2, x minus 5. Put these two numbers in the parentheses. Then when we have two functions multiplied to be 0, we set each of them equal to 0, solve for x. X plus 2 equals 0, x minus 5 equals 0. Set each of them equal to 0, solve for x. First equation, I can subtract 2 from both sides. I get s equal to negative 2. For the second equation, I can add 5 to both sides. I get s equal to positive 5. Now let's check make sure the answer is valid. Let's check the answer. Check the denominator. Make sure this answer is valid. Let's plug in negative 2 first. If I substitute negative 2 into the LCD, negative 2 plus 1 is not 0. So that's okay. Negative 2 plus 2 is 0. Negative 2 plus 2 is 0. And 0 times everything is 0. So this answer is invalid. If the solution make LCD 0, this solution is invalid. It must be rejected. This solution is invalid. It must be rejected. If the solution make LCD 0, this solution must be rejected. Let's check the other solution. If I substitute 5, 5 plus 1 is not 0. 5 plus 2 is also not 0. So number 5 is valid. This number 5 is valid. So there's only one solution, s equal to 5. There's only one solution, s equal to 5. Negative 2 is rejected. Number 10. X over s squared minus 1 plus 2 over s plus 1 equal to 1 over 2x minus 2. So same procedure. We first of all try to factor the denominator first, then find the least common denominator. First denominator, s squared minus 1. S squared is a perfect square. X times x is s squared. Number 1 is also perfect square. 1 times 1 is 1. Then use the formula. S plus 1, x minus 1. That's the first denominator. S plus 1, s minus 1. The second term, denominator is not factorable. I leave it the way it is. For the third term, on the denominator, I can try to factor 2 out. On the third term here, I can try to factor 2 out. That's the largest number that divides both numbers. So, from the first term, if I pull out 2, that's x left. For the second term, if I pull out 2, I take 2 divided by 2, which is 1. That's the last term. Next, we try to find the least common denominator. Least common denominator must include every factors in the denominator. So it must include s plus 1, x minus 1. We have s plus 1 already, don't repeat. And third term, we need to have a 2 on the bottom. We need to have a 2 on the denominator. So we need 2 on the denominator. We have s minus 1 already, don't repeat s minus 1. So this is the least common denominator. Next, we try to rewrite every fraction over the least common denominator. If we compare the first fraction, if we compare the first denominator with the LCD, what's missing is number 2. if we compare the first fraction of LCD, what's missing is number 2. So I multiply number 2 to the top and the bottom. Second term, if we compare the denominator of LCD, what's missing is number 2 and x minus 1. What's missing is number 2 and x minus 1. Multiply the same thing to the top and the bottom. Then when we multiply the denominator, it looks exactly the same as LCD. Last term, 1 over 2 times x minus 1. If we compare the denominator with LCD, what's missing is x plus 1. What's missing is x plus 1. So we multiply the missing factor to the bottom and the top. After we multiply out, we can see that every denominator looks exactly the same. When the denominator of every term looks exactly the same, we can drop the common denominators. When we are solving equation, if every denominator looks exactly the same, we can drop the common denominators. So we have x times 2. First term we have x times 2. Second term we have 2 times 2x minus 1. Third term we have 1 times x plus 1. Then the first term, x times 2 is 2x. Second term, 2 times 2 is 4. If we distribute 4, we have 4x minus 4. 2 times 2 is 4. If we distribute 4, 4 times x is 4x. 4 times 1 is 4. Last term, distribute 1. 1 times x is 1x. 1 times 1 is 1. Then on the left side, I can try to combine like term first. 2x plus 4x is 6x. 1x plus 1, that cannot be simplified, leave it the way it is. Then we solve the equation for x. I can first of all subtract 1x from both sides. On the right side, positive 1x and negative 1x can cancel. We get number 1 by itself. On the left side, 6x minus 1x is 5x. Keep minus 4 the same. Next, I can try to eliminate negative 4 first. Add 4 to both sides. On the left side, negative 4 positive 4 can cancel. We get 5x by itself. On the right side, 1 plus 4 is 5. Next, I can divide both sides by 5. Then, number 5 on the top and the bottom get cancelled. We get s by itself. On the right side, 5 divided by 5 is 1. So the solution is s equal to 1. Now let's verify. Is this answer valid? Let's verify. Is this answer valid? If we plug in 1 into the LCD, 1 plus 1 is not 0, it's 2. 1 minus 1 is 0. 0 times everything is 0. So this number 1 makes denominator 0. Number 1 is invalid. This answer must be rejected. Since number 1 makes denominator 0, this answer must be rejected. So since there's only one solution and it's rejected, that means there are no solutions. Since there's only one solution and it's rejected, that means there are no solutions. That was what we did last class. Today, we will study radical expression. Radical expression, a special case is square root. A special case of radical expression is square root. Today, let's focus on square root. What's a square root? Let x be a non-negative real number Let x be a non-negative real number if x times x equal to y. If x times x equal to y, then we say square root of y is x. If x times x equal to y, then we say square root of y equal to x. For example, if 4 times 4 is 16, then we say square root of 16 is 4. 7 times 7 is 49, then we say square root of 49 is 7. 10 times 10 is 100. 10 times 10 is 100, then we say square root of 100 is 10. That's what square root means. Next, let's look at some example about square roots. What's square root of 9? What's square root of 9? We know that 3 times 3 is 9. 3 times 3 is 9. So square root of 9 is 3. What's square root of 25? We know that 5 times 5 is 25. So square root of 25 is 5. What's square root of 81? We know that number 9 times number 9. 9 times 9 is 81. 9 times 9 is 81. So square root of 81 is 9. What's square root of 36? We know that 6 times 6 is 36. So square root of 36 is 6. What's square root of 64? We know that a times a is 64. We know that a times a is 64. So square root of 64 is 8. What's square root of 1? What's square root of 1? We know that 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. So square root of 1 is 1. What's square root of 0? What's square root of 0? We know that 0 times 0 is 0. So square root of 0 is 0. Square root of 0 is 0. Because 0 times 0 is 0. What's square root of -4? Be very careful. What's square root of -4? Can we find a number that multiplied by itself give you -4? Can we find a number that multiplied by itself give you -4? If we try 2, 2 times 2 is +4, it's not -4. So 2 won't work. How about -2? -2 times -2 is also +4. Double negative is positive. -2 times -2 is also +4. So we can find such numbers. There's no such number that multiplied by itself give you -4. There are no such numbers that multiplied by itself give you -4. So square root of -4 is undefined. Square root of -4 is undefined. So keep it in mind that square root of any negative number square root of any negative number is undefined. Square root of any negative number is undefined. Keep it in mind. Let's continue. Next, what's square root of negative 5 square? What's square root of negative 5 square? For square root of negative 5 square, we do the square first. Negative 5 square means negative 5 times negative 5. Negative 5 square means negative 5 times negative 5. And when we multiply, double negative is positive. That's square root of positive 25. Square root of 25 is 5 because 5 times 5 is 25. So square root of 25 is 5. What's square root of negative 5 square without parentheses? What's square root of negative 5 square without parentheses? If there's no parentheses, that's square root of negative 5 times 5. Square only apply to number 5, not a negative sign. So we have negative 5 times 5, which is square root of negative 25. Square root of negative 25 is undefined. Square root of any negative number is undefined. Next, what's square root of 2 times square root of 18? What's square root of 2 times square root of 18? For square root, there's a formula. Keep it in mind. That square root of x times square root of y, that's always the same as square root of x times y. If there are two square roots multiplied together, we keep square root, multiply the numbers under square root. Square root of x times square root of y is square root of x times y. And same thing works for division. Square root of x divided by square root of y. Square root of x divided by square root of y. We can put both of them under one square root, like this. Square root of x divided by y. So for square root, when we have multiplication and division, we can put both factor under one square root. For multiplication and division, we can put both factor under one square root. But it doesn't work for addition and subtraction. It doesn't work for addition and subtraction. For addition, square root of x plus square root of y is not the same as square root of x plus y. And same thing for subtraction, they are not the same. We can combine two square roots for addition and subtraction, but we are allowed to combine square roots for multiplication and division. For addition and subtraction, we are not allowed to combine two square roots together, but for multiplication and division, we are allowed to combine two square roots together. Number 11, square root of 2 times square root of 18. For multiplication, I can put both numbers under one square root. 2 times 18 is 36. 2 times 18 is 36. Square root of 36 is 6. Let me show you the work here. 2 times 18. For square root, we can put, for multiplication, we can put both numbers under one square root. We have square root of 2 times 18 under one square root. Then 2 times 18 is 36. Square root of 36 is 6, because 6 times 6 is 36. So square root of 36 is 6. Next, square root of 3 times square root of 27. Square root of 3 times square root of 37. So when we have two square roots multiplied together, we can multiply the numbers under square root. We have 3 times 27. When we have two square roots multiplied together, we can multiply the number under square root. 3 times 27 is 81. Square root of 81 is 9. Next, square root of 5 times square root of 20. Square root of 5 times square root of 20. we can multiply two square roots together. I can write it as square root of 5 times 20. 5 times 20 is 100. Square root of 100 is 10, because 10 times 10 is 100. Next, what's square root of 54 over square root of 6? What's square root of 54 over square root of 6? So when we divide two square roots, we can put both square root, we can put them under one square root. Square root of x divided by square root of y. We can put both of them under one square root. Write it as square root of 54 over 6. We can put both factors under one square root. I get square root of 54 over 6. And we know 54 divided by 6 is 9. Square root of 9 is 3. Square root of 9 is 3. Next. Square root of 75 over square root of 3. Square root of 75 over square root of 3. For division, we can put both numbers under one square root. 75 over 3. For division, we can put both numbers under one square root. 75 divided by 3 is 25. Square root of 25 is 5, because 5 times 5 is 25. So square root of 25 is 5. Next, square root of 60 over square root of 15. Square root of 60 over square root of 15. We can put both square root under one square root. For division, we can put two square root under one square root. 60 over 15. Square root of 60 over 15. If I divide the numbers, 60 divided by 15 is 4. Square root of 4 is 2. Next. What's square root of 6 square? Square root of 6 square, it can be rewritten as square root of 6 times square root of 6. Square root of 6 square can be rewritten as square root of 6 times square root of 6, which is, you can multiply both numbers under square root. 6 times 6 is 36. We can multiply both numbers under one square root. 6 times 6 is 36. When we have two square roots multiplied together, we can multiply the numbers under one square root. 6 times 6 is 36. Square root of 36 is 6. Next. What's square root of a square? What's square root of a square? Square root of a square can be rewritten as square root of a times square root of a. We have two square roots multiplied together. We keep the square root, multiply the numbers under square root. A times a is 64. Keep square root, multiply the numbers under square root. A times a is 64. Square root of 64 is 8, because a times a is 64. Next, what's square root of 2 square? What's square root of 2 square? Square root of 2 square is square root of 2 times square root of 2. If we multiply both square roots, we keep square root, multiply numbers under square root. That's 4. 2 times 2 is 4. Square root of 4 is 2, because 2 times 2 is 4. Next example, be very careful. Next example, square root of -2 square. Be very careful. Square root of -2 square. That's square root of -2 times square root of -2. But here, a negative number under square root is undefined. A negative number under square root is undefined. This is undefined. This is also undefined. We cannot multiply undefined numbers. We can multiply undefined numbers. They are both undefined. We are not allowed to multiply undefined numbers. So the final answer is undefined. We can multiply undefined numbers. Square root of negative number is undefined. Square root of negative number is undefined. If they are both undefined, we can multiply undefined numbers. The answer is undefined. Be very, very careful. Square root of negative number is always undefined. Be very, very careful. Square root of negative number is always undefined. They are both undefined numbers. We can multiply -2 by -2. They are both undefined numbers. Square root of negative number is undefined. We can multiply undefined numbers. Be very, very careful. So, in order to make square root easier, I suggest you memorize some perfect squares. In order to take square root easily, I suggest you memorize some perfect squares. 1 square is 1. 2 square is 4. 3 square is 9. 4 square is 16. 5 square is 25. 6 square is 36. 7 square is 49. 8 square is 64. 9 square is 81. 10 square is 100. 11 square is 121. 12 square is 144. 13 square is 169. 14 square is 196. 15 square is 225. 16 square is 256. 17 square is 289. 18 square is 324. 19 square is 361. 20 square is 400. Those are some perfect squares. They are here. We have 20 perfect squares here. If you can multiply all of them, at least multiply the first 10. If you can multiply all of them, at least multiply the first 10 perfect squares. They'll be easier. They will make the problem easier. If you can, I suggest you multiply all 20 perfect squares. But if you can remember everything, I suggest you memorize everything. But if you can memorize everything, at least memorize the first 10 perfect squares. At least memorize the first 10 perfect squares. Let's continue. Next example. What's square root of 12? What's square root of 12? 12 is not a perfect square. What should we do? 12 is not a perfect square. 12 is not a perfect square. What should we do? Can we find two numbers that multiply to be 12? Can we find a number that multiplied by itself equal to 12? It looks impossible. We can't find a number multiplied by itself give you 12. That's impossible. 12 is not one of these perfect squares. 12 is not a perfect square. Then how do we take square root of 12? If 12 is not a perfect square, we try to find a perfect square factor for 12. Which of these number divides 12? Which of these number divides 12? Here we can see that number 4 divides 12. 12 can be rewritten as square root of 4 times square root of 3. I can split 12 as 4 times 3. 4 is a perfect square. If you do 2 times 6, it won't work. 2 is not perfect square. 6 is not perfect square. If you separate it as 2 times 6, it won't work. If you must separate it as a perfect square times another number. It must be a perfect square times another number. So 4 is a perfect square factor for 12. Number 4 is a perfect square factor for 12. And we know that square root of 4 is 2. Square root of 3 cannot be reduced. I leave it the way it is. So that's the final answer. Square root of 12 is 2 square root of 3. Square root of 12 is 2 square root of 3. Next. Square root of 18. Can we find a perfect square factor for 18? Can we find a perfect square factor for 18? A factor of 18 must be less than 18. Can we find a perfect square factor for 18? Here we can see that a perfect square factor for 18 is 9. 9 divides 18. 9 goes into 18 2 times. Square root of 9 is 3. We can reduce square root of 2, so I leave it the way it is. The answer is 3 square root of 2. The answer is 3 square root of 2. Next. What's square root of 50? Can we find a perfect square factor for 50? A perfect square factor of 50 must be less than 50. 49, 36, 25, 16, 9, 4, and 1. Which number divides 50? 49, 36, 25, 16, 9, and 4. It looks like 25 divides 50. 25 goes into 50 2 times. 25 goes into 50 2 times. I can write 50 as 25 times 2. Square root of 25 is 5. Square root of 25 is 5. Square root of 2 cannot be reduced. I leave it the way it is. Next. What's square root of 20? What's square root of 20? When the 20 is not perfect square, can we find a perfect square factor for 20? Can we find a perfect square factor for 20? Can we find a perfect square factor for 20? A perfect square factor of 20 must be less than 20. 16, 9, and 4. It looks like 4 is a factor of 20. 4 goes into 20 5 times. Square root of 4 is 2. Square root of 5 cannot be reduced. I leave it the way it is. So the answer is 2 square root of 5. Next. Square root of 24. In order to simplify square root of 24, we try to find a perfect square factor for 24. A perfect square factor must be less than 24. 16 doesn't work. 9 doesn't work. 4 divides 24. 4 divides 24. 24 can be written as 4 times 6. Square root of 4 is 2. We can simplify square root of 6 and leave it the way it is. That's the final answer. Next. Square root of 60. Square root of 60. We try to find a perfect square factor for 60. A perfect square factor of 60 must be less than 60. What do we have here? 49, 36, 25, 16, 9, 4. It looks like only number 4 works. Only number 4 divides 60. Only number 4 divides 60. 4 goes into 60 15 times. I can write 60 as 4 times 15. Square root of 4 is 2. Square root of 15 cannot be reduced. I leave it the way it is. So the answer is 2 square root of 15. Next. Square root of 72. We try to find a perfect square factor for 72. A perfect square factor for 72 must be less than 72. We have 64, 49, 36. It looks like 36 works. 36 goes into 72 2 times. Square root of 72 can be written as 36 times 2. 36 goes to 72 2 times. So 72 can be written as 36 times 2. Square root of 36 is 6. We can simplify square root of 2. We leave it the way it is. Next, square root of 27. We try to find a perfect square factor for 27. A perfect square factor of 27 must be less than 27. What do we have here? We have 25, 16, 9, 4. It looks like 9 works. 9 goes to 27 3 times. 27 can be written as 9 times 3 because 9 goes into 27 3 times. Square root of 9 is 3. Square root of 9 is 3. We can reduce square root of 3, so leave it the way it is. That's an answer. Next, square root of 180. Square root of 180. Can we find a perfect square factor for 180? That's which number here goes to the 180 evenly? That's 100 divided 180, 81, 64, 49, 36. 36 works. 36 times 5 is 180. 36 times 5 is 180. That means 36 goes to 180 exactly 5 times. 36 times 5 is 180. Square root of 36 is 6. Square root of 5 cannot be reduced. I leave it the way it is. So the answer is 6 square root of 5. Next, square root of 162. Square root of 162. We try to find a perfect square factor for 162. We try to find a perfect square factor for 162. Does any number work here? Does any number works here? Does any number works? Does any number work here? 100 doesn't divide 162. 81 divided 162. Square 81 times 2 is 162. 81 times 2 is 162. So square root of 162 can be written as square root of 81 times square root of 2. 81 times 2 is 162. So square root of 162 is 81 times 2. Square root of 81 is 9. Square root of 2 cannot be reduced. We leave it the way it is. Next. What's 2 square root of 2 square? What's 2 square root of 2 square? Be very careful. 2 square root of 2 square. 2 square root of 2 means 2 square root of 2 times 2 square root of 2. That's what square means. 2 square root of 2 square means 2 square root of 2 times 2 square root of 2. We first of all multiply the numbers outside square root. We first of all multiply numbers outside square root. 2 times 2 is 4. Then we multiply numbers under square root. Then we multiply numbers under square root. 2 times 2 under square root is also 4. Square root of 4 cannot be reduced. I leave it the way it is. Number 4, this number 4 cannot be reduced. I leave it the way it is. Square root of 4 is 2, because 2 times 2 is 4. Square root of 4 is 2. The first 4 is outside square root. I leave it the way it is. The first 4 is outside square root. I leave it the way it is. Second 4 is under square root. I take square root for this number. Square root of 4 is 2, because 2 times 2 is 4. Then for the final answer, 4 times 2 is 8. Next. Five square root of 3 cube. 5 square root of 3 cube. What does it mean? Cube. That means power 3. That means we have 5 square root of 3 times 5 square root of 3 times another 5 square root of 3. That's what power 3 means. 5 square root of 3 times 5 square root of 3 times another 5 square root of 3. We first of all multiply the numbers outside square root first. We first of all multiply numbers outside square root first. 5 times 5 times 5. That's 25. 5 times 5 times 5, that's 25. So that's 125. 5 times 5 is 25. 25 times 5 is 125. 5 times 5 times 5. 5 times 5 is 25. 25 times the third 5 is 125. Then for the numbers under square root, 3 times 3 is 9. 9 times 3 is 27. 125 is outside square root. It cannot be reduced. We leave it the way it is. 125 is outside square root. We don't reduce it. Leave it the way it is. For the number outside square root, don't touch it. Leave it the way it is. For the number under square root, we have to simplify. Square root of 27. 27, can we find a perfect square factor for 27? Can we find a perfect square factor for 27? Perfect square factor of 27 must be less than 27. Let's try. That's 25 divided by 27. That's 16. How about 9? Yes, 9 divided by 27. 9 divided by 27. 9 goes into 27 exactly 3 times. So 27 can be written as square root of 9 times square root of 3. 27 can be written as 9 times 3. Square root of 9 can be reduced as 3. Square root of 9 is 3 because 3 times 3 is 9. Square root of 3 cannot be reduced. I leave it the way it is. Then for the final answer, don't forget there is 125 outside square root. For the final answer, don't forget there is 125 outside square root. So for the final answer, 125, we multiply number outside square root. 125 times 3 is 375. 125 times 3 is 375. Keep square root the same. That's the answer. 375. Square root of 3. That's the final answer. Next, let me introduce the Pythagorean Theorem. Pythagorean Theorem says, for any right triangles with two legs A, B, and a hypotenuse C, we always have A squared plus B squared equal to C squared. For any right triangle with two legs A, B, and hypotenuse C, we always have A squared plus B squared equal to C squared. The picture looks like this. A right triangle, one of the angle must be a right angle. In a right triangle, one of the angle must be a right angle. Right angle means a 90-degree angle. The two legs are the sides next to the right angle. These two sides, they are called legs. The side next to the right angle, they are called legs. We have two sides next to the right angle, they are called legs. This is also leg. The side opposite the right angle is called hypotenuse. The sides next to the right angle, they are called legs. The side opposite the right angle is called hypotenuse. And usually we call the two sides, these two legs A and B. We call this hypotenuse C. We call these two legs A and B. We call the hypotenuse C. That's Pythagorean Theorem. Next, let's do some example for Pythagorean Theorem. For each of the following right triangles. Find its missing side. For each of the following right triangles, find its missing side. First example, we have a triangle looks like this. We have two sides, 3 and 4. One side is missing. Find the missing side. Find the missing side. Usually we call the missing side x. Find the missing side. First step, label ABC first. First step, label ABC first. A and B represent two legs. A and B represent two legs. So the legs on the side next to the right angle. So we have A equal to 3, B equal to 4. The legs on the side next to the right angle. And C is the hypotenuse, which is the side opposite to the right angle. So C is x. In this problem, C is x. Then use the formula. A squared plus B squared equal to C squared. Plug in A, B, and C. A is 3, B is 4, C is x. 3 squared is 9, 4 squared is 16. We are looking for x. S squared stays the same. 9 plus 16 is 25. So s squared equal to 25. S squared equal to 25. X squared equal to 25 means x equal to square root of 25. If x squared is 25, that means x by itself equal to square root of 25. And we know that square root of 25 is 5. So the answer is 5. The missing side is 5. Next. In this triangle, this side is 5, this side is 13. Find the missing side. We have one side is 5 here, one side is 13 here. Find the missing side. Usually we call the missing side x. First of all, label ABCs. First of all, label ABC. Then use Pythagorean Theorem to find the missing side. Let's label ABC first. A and B are legs. Legs on the side next to the right angle. Right angle is here. Two legs here is 5 and x. The right angle is here. We have two legs, 5 and x. That's A, that's B. The side opposite to the right angle is called hypotenuse. So C is 13. The side opposite to the right angle is called hypotenuse. So C is 13. Then use Pythagorean Theorem. A squared plus B squared equal to C squared. 5 squared plus x squared equal to 13 squared. A is 5, B is x, C is 13. 5 squared is 25. 13 squared is 169. Subtract 25 from both sides. S squared is 144. S squared is 144. X squared is 144. That means x is square root of 144. X squared is 144 means x is square root of 144. And we know that square root of 144 is 12 because 12 times 12 is 144. Square root of 144 is 12 because 12 times 12 is 144. So the answer is 12. The missing side is 12. Next, in this triangle, we have two sides, 15 and 17. We're looking for the missing side. Usually we call the missing side x. Then we try to label A, B, C first. Let's label A, B, C first. A and B are two legs. Legs on the side next to the right angle. A and B are two sides next to the right angle. C is the side opposite to the right angle. Let's call hypotenuse. C is the side opposite to the right angle. Then we can use Pythagorean Theorem. A squared plus B squared equal to C squared. A is x, B is 15, C is 17. Then solve the equation for x. X squared stays the same. 15 squared means 15 times 15, which is 225. 17 squared means 17 times 17, which is 289. Then we can subtract 225 on both sides. On the left side, we get x squared by itself. On the right side, 289 minus 225 is 64. 289 minus 225 is 64. If x squared is 64, x must be square root of 64. If x squared is 64, x by itself must be square root of 64. And we know square root of 64 is a, because a times a is 64. Next. We have two sides, 2 and 4 here. One side is missing. We have two sides, 2 and 4 here. One side is missing. Usually we call the missing side x. Then next we label A, B, C. A, B, C, A and B are two legs. Legs on the side next to the right angle. C is the side opposite to the right angle. So C is 4 here. Then use Pythagorean Theorem. A squared plus B squared equal to C squared. A is x. B is 2. C is 4. Keep x squared the same. 2 squared is 4. 4 squared is 16. Next, I can subtract 4 from both sides. On the left side, positive 4 and negative 4 can cancel, we get x squared by itself. On the right side, 16 take minus 4 is 12. X squared is 12. That means x is square root of 12. X squared is 12 means x is square root of 12. Can we reduce square root of 12? Square root of 12 is not a perfect square. Let's try to reduce it. Let's try to find a perfect square factor for 12. A perfect square factor for 12 is 4. And 12 is 4 times 3. 12 can be written as 4 times 3. Square root of 4 is 2. We can reduce square root of 3. Leave it the way it is. So that's the final answer. The missing side is 2 square root of 3. Next. In this triangle, one side is missing here. Find the missing side. One side is missing here. Find the missing side. Usually we call the missing side x. Then we try to label A, B, C for these three sides. Next, try to label A, B, C for these three sides. A and B are two legs. Legs are next to the right angle. And the side opposite to the right angle is C. The side opposite to the right angle is C. Then use Pythagorean Theorem. A squared plus B squared equal to C squared. A is 5. B is also 5. C is x. 5 squared is 25. 5 squared is 25. Equal to x squared. 25 plus 25 is 50. So 50 is x squared. If x squared equal to 50, that means x equal to square root of 50. If x squared is 50, that means x by itself is square root of 50. Can we reduce square root of 50? 50 is not perfect square. Can we reduce square root of 50? We try to find a perfect square factor for 50. For 50, a perfect square factor is 25. 25 goes into 50 two times. Square root of 25 is 5. Square root of 2 cannot be reduced. So that's the final answer. The missing side is 5 square root of 2. The missing side is 5 square root of 2. Next. We have two sides. We know two sides. One side is missing here. Usually we call the missing side x. Next, try to label ABC in the triangle. Next, try to label ABC in the triangle. A and B are two legs. A is 6, B is x. C is the side opposite to the right angle. So C is 9. Then use the formula. A squared plus B squared equal to C squared. We have 6 squared plus x squared equal to 9 squared. 6 squared is 36. X squared stays the same. 9 squared is 81. Next, I can subtract 36 from both sides. If I subtract 36 from both sides, x squared is 81 minus 36. On the left side, 36 can cancel. On the right side, 81 minus 36 is 45. So x squared is 45. If x squared is 45, that means x by itself is square root of 45. If x squared is 45, that means x by itself is square root of 45. 45 is not a perfect square, so we try to reduce it. Can we find a perfect square factor for 45? A perfect square factor for 45 is 9. 9 is a perfect square, and it goes into 45 5 times. Square root of 9 is 3. Square root of 5 cannot be reduced. So the final answer is 3 square root of 5. That's the final answer. 3 square root of 5. That's the missing side. Next. One side is 1, another side is 2. The third side is missing. Find the missing side. One side is 1, one side is 2. A third side is missing here. find the missing side. Usually we call the missing side x. Next, label the triangle. Label ABC the triangle. A and B are two legs. The legs are next to the right angle. A and B are two legs. The side opposite to the right angle is C. So use Pythagorean Theorem, use the formula. A squared plus B squared equal to C squared. 1 squared plus 2 squared equal to x squared. 1 squared plus 2 squared equal to x squared. 1 squared is 1. 2 squared is 4. 1 plus 4 is 5. If x squared is 5, that means x must be square root of 5. Square root of 5 cannot be reduced. There's no perfect square factor. Square root of 5 cannot be reduced because it has no perfect square factor. So that's the final answer. Square root of 5 cannot be reduced. So that's your final answer. Next. We have square root of 2, square root of 2. One side is missing. We have two sides, square root of 2 and square root of 2. One side is missing here. So first step, let's call the missing side x. Then label the triangle with A, B, and C. Label the triangle with A, B, and C. A and B are two legs. A and B are two legs. The legs are next to the right angle. So A and B are two legs. C is the side opposite to the right angle. C is the side opposite to the right angle. C is the side opposite to the right angle, which is x. Which is x. So use Pythagorean Theorem. A squared plus B squared equal to C squared. We have square root of 2 squared plus square root of 2 squared equal to s squared. What's square root of 2 squared? What's square root of 2 squared? Square root of 2 squared can be rewritten as square root of 2 times square root of 2, which is, when we multiply two numbers under square root, we multiply the number under square root first. When we multiply two numbers under square root, keep square root, multiply number first. 2 times 2 is 4. Square root of 4 is 2. So square root of 2 squared is 2. Same thing, square root of 2 squared is 2. 2 plus 2 is 4. S squared is 4. If s squared is 4, that means x is square root of 4. Square root of 4 is 2. So the missing side x is 2. The missing side x is 2. Missing side is 2. Next. We have two sides. Square root of 5, square root of 13. We are looking for the missing side. We have two sides, square root of 5 and square root of 13. We are looking for the missing side. Usually we call the missing side x. Then we label the triangle with ABC. Usually we call the missing side x. Then we label the triangle with ABC. A and B are two legs. Legs are next to the right angle. So we have A and B. C is the side opposite to the right angle. This side is C. C equal to square root of 13. Then use Pythagorean Theorem. A squared plus B squared equal to C squared. We have square root of 5 squared plus x squared, b is x, equal to square root of 13 squared. What's square root of 5 squared? Square root of 5 squared is square root of 5 times square root of 5. Square root of 5 times square root of 5. We keep square root. Multiply the numbers under square root. 5 times 5 is 25. And square root of 25 is 5. Square root of 5 squared. So square root of 5 squared is 5. Plus s squared. What's square root of 13 squared? We know square root of 5 squared is 5. In the previous problem, we see that square root of 2 squared is 2. Do we see the pattern here? Square root of 2 squared is 2. Square root of 5 squared is 5. Square root of 13 squared. Do you see the pattern here? It should be 13. In general, square cancel square root. In general, square cancel square root. Square cancel square root. We have number 5 by itself. So similarly, square cancel square root. We have number 13 by itself. Next, solve an equation for x squared. I can subtract 5 from both sides. x squared equal to a. If x squared is a, that means x must be. If x squared is a, that means x must be square root of a. X must be square root of a. Square root of a. A is not perfect square. Let's try to find a perfect square factor for a. Number a is not perfect square. It's not perfect square. Let's find a perfect square factor for a. A perfect square factor for a is number 4. A equal to 4 times 2. Square root of 4 is 2. Square root of 2 cannot be reduced. I leave it the way it is. So the final answer is 2 square root of 2. That's the missing sign. The missing sign is 2 square root of 2. Next. In a right triangle, 2 sides are given. That's number 5. That's square root of 29. 2 sides are given. Find the missing side here. Usually we call the missing side x. First of all, let's label ABC. Let's label ABC to this triangle. A and B are 2 legs. The legs are the side next to the right angle. So A and B are 2 legs. C is the side opposite to the right angle. Let's see. Then once I label ABC, we use Pythagorean Theorem. A squared plus B squared equal to C squared. A is x. B is 5. C is square root of 29. X squared stays the same. 5 squared is 25. Square root of 29 squared is 29. Square cancels square root. Square root of 29 squared is 29. Then solve an equation for x. I can first of all subtract 25 from both sides. On the left side, 25 can cancel. We get x squared by itself. On the right side, 29 minus 25 is 4. We have x squared equal to 4. X squared equal to 4. That means x equal to square root of 4. X squared equal to 4 means x equal to square root of 4. Square root of 4 is 2. So the missing side is 2. Next, let's do some calculation with variables, with letters. Simplify each of the following expressions. square root of s squared. How do we simplify square root of s squared? So for square root of s squared, if the power is even, we take half of the power. If the power is even, take half of the power. 2 divided by 2 is 1. X to the power 1 is x. If the power is even, take half of the power. Square root of x to the power 6. If the power is even, take half of the power. Square root of x to the power 6. If the power is even, take half of the power. Half of 6 is 3. 6 divided by 2 is 3. Next, square root of y to the power of a. Square root of y to the power of a. If the power is even, take half of the power. Half of a is 4. If the power is even, take half of the power. Half a divided by 2 is 4. Square root of y to the power of 10. Square root of y to the power of 10. If the power is even, if the exponent is even, take half of the power when we're taking square root. If the exponent is even, take half of the exponent. Half of 10 is 5. Next, or if the power is odd, or if the power is odd, y to the power of 11, or if the power is odd. If the power is odd, we try to make it even. I can take away 1, make it even. Y to the power 11 means there are 11y multiplied together. Take away 1y, I can make it even. Take away 1y, I can make it even. Y to the power of 11 means there are 11 y's multiplied together. If I take away 1y, I can make the power even. Then y to the power 10. If the power is even, take half of the power. Half of 10 is 5. And square root of y, I leave it the way it is. That's the final answer. Y to the power of 5, square root of y. Next, x to the power of 17. X to the power of 17. If the power is odd, we try to make it even by taking away 1. X to the power 17, take away 1. I have x to the power 16 times square root of x. Take away 1. X to the power 17 means there are 17x multiplied together. Take away 1. I have 16x left. Then the power is even. Take half of the power, x to the power 8. Leave square root of x the way it is. That's the final answer. Next, y to the power of 25. Y to the power of 25. If the power is odd, take away 1, make it even. I have y to the power 24 times square root of y. When the power is even, take half of the power. When the power is even, take half of the power. 24 divided by 2 is 12. And square root of y stays the same. That's the final answer. X to the power of 27. X to the power of 27. If the exponent is odd, take away 1, make it even. 27 minus 1 is 26. Then x to the power 26. If the power is even, take half of the power. I get x to the power of 13. Square root of x, I keep it the same. Keep square root of x the same. That's the final answer. Now, next. How do we simplify this? Square root of 36 times x to the power of 4. square root of 36 times x to the power of 4. So when we have a number times a variable, separate the number and the variable first. When there's a number times x, separate the number and x first. We have square root of 36 times square root of x to the power of 4. Square root of 36 times square root of x to the power of 4. Solve each part individually. Square root of 36 is 6 because 6 squared is 36. Square root of x squared, square root of s squared, square root of x to the power 4 is s squared. Square root of x to the power 4 is s squared. When the power is even, take half of the power. 4 divided by 2 is 2. When the power is even, take half of the power. 4 divided by 2 is 2. So that's the final answer. Next, 20 square root of 20 x to the power of 6. Square root of 20 x to the power of 6. So we first of all separate the numbers and the variables first. Square root of 20 times square root of x to the power of 6. Square root of 20 times square root of 6. Square root of 20 is not a perfect square. It can be reduced as. Okay, let's find a perfect square factor for 20 first. A perfect square factor for 20 is 4. 20 is 4 times 5. Square root of 4 is 2. Square root of 5 cannot be reduced. Square root of x to the power 6, when the power is even, we can take half of the power. That's x to the power of 3. When the power is even, take half of the power. That's x to the power of 3. Then, for the final answer, we multiply the number outside square root together. We have 2x to the power 3 and multiply the number under square root together times square root of 5. For the final answer, we multiply the number outside square root together, 2x to the power of 3, and keep the number under square root by itself. Next. Square root of 18y to the power of 4. Square root of 18y to the power of 4. Square root of 18y to the power of 4. So let's separate the number and the variable first. We have square root of 18, square root of y to the power of 4. Let's simplify 18 first. 18 is not a perfect square. 18 is not a perfect square. Let's try to find a perfect square factor for 18 first. For 18, a perfect square factor is 9. 9 is a perfect square, and 9 goes to 18 2 times. 18 can be written as 9 times 2. Square root of 9 is 3. Square root of 2 cannot be reduced. We leave it the way it is. Y to the power of 4. When the power is even, we take half of the power. Half of 4 is 2. So, for the final answer, we multiply the number outside square root together. The number outside square root, we have 3y squared. And keep the number under square root by itself. The number under square root is square root of 2. The number under square root is square root of 2. We keep the way it is. Next. Square root of ax to the power of 7. Square root of ax to the power of 7. We first of all separate the number and letters. Ax to the power of 7. Simplify number a first. Number a is not perfect square. Number A is not a perfect square, but it can be written as square root of 4 times square root of 2. 4 is a perfect square factor for number A. And square root of 4 is 2. Square root of 2 cannot be reduced. I leave it the way it is. X to the power of 7. When the power is odd, for any letter, if the power is odd, take away 1, make it even. Power 7, 7 is odd, take away 1, make it even. Square root of x to the power of 6, if the power is even, take half of the power. If the power is even, take half of the power. 6 divided by 2 is 3. Square root of x cannot be reduced. I leave it the way it is. For the final answer, we multiply the number outside square root together, and we multiply number under square root together. Under square root we have 2x, square root of 2x, under square root 2x. Outside square root is 2x cubed, under square root we have 2x. Next. Square root of 18, x to the power of 4, y to the power of 9. Square root of 18, x to the power of 4, y to the power of 9. So, first of all, separate the number and the letters. I have square root of 18, x to the power of 4, y to the power of 9. Separate the number and the letters. First step, separate number and letters first. Then simplify each part individually. Then combine them together at the end. Simplify each of them individually. Then combine the answer at the end. Square root of 18. 18 is not a perfect square. Let's try to find a perfect square factor for 18 first. Let's find a perfect square factor for 18 first. For number 18, 9 is a perfect square factor. And 18 can be written as 9 times 2. Square root of 9 is 3. Square root of 2 cannot be reduced. X to the power 4. Here the power is even. When x raised to an even power, we take half of the power. 4 divided by 2 is 2. Y raised to power 9. Here y has an odd power. Y has an odd power. When the power is odd, take away 1, make it even. When the power is odd, take away 1, make it even. Y to the power a has an even power. When the power is even, take half of the power. A divided by 2 is 4. Square root of y cannot be reduced. I leave it the way it is. For the final answer, multiply the number outside square root together. For the final answer, multiply numbers outside square root together. We have 3 s squared y to the power 4. 3 s squared y to the power 4. And multiply number under square root together. Under square root we have 2 square root of 2 square root of y, which is square root of 2y. That's the final answer. Next. -2 square root of 12 x to the power of 7. -2 times square root of 12 x to the power of 7. So when we simplify square root, we don't really care what number is in the front. Don't worry about this number. Simplify square root first, then multiply this number to the final answer. Don't worry about this number for now. Simplify square root first. The number under square root is 12 and x to the power of 7. Square root of 12. 12 is not a perfect square. 12 is not a perfect square. We try to simplify 12 first. Square root of 12 can be written as 4 times 3. Number 4 is a perfect square. Square root of 4 is 2. Square root of 3 cannot be reduced. Now for x to the power of 7, when the power is odd, take away 1, make it even. When the power is odd, take we want, make it even. Then for x raised to the power of 6, we can take half of the power. This is even. I can take half of the power. That's x raised to the power 3. Square root of x cannot be reduced, leave it the way it is. Then we multiply a number outside square root. Don't forget, we have -2 in the front. Don't forget there's a -2 in the front. Then for the final answer, multiply numbers outside square root together. Multiply numbers outside square root together. We have -2 times 2 is -4. -4 times x to the power 3 is -4x to the power of 3. -4 times x to the power of 3 is -4x to the power of 3. The number under square root is 3x. That's the final answer. Next. Negative square root of x to the power of 7, y to the power of 13. Negative x to the power of 7, y to the power of 13. Don't worry about this negative sign. Simplify the square root first. Don't worry about this negative sign. Simplify the square root first. Separate letter x and y. X to the power 7, y to the power of 13. When the power is odd, take we want, make it even. When the power is odd, take we want, make it even. Y to the power 12 times y. When the power is odd, take we want, make it even. Then we have even power here. For x raised to the power 6, I take half of the power, that's x to the power of 3. Square root of x cannot be reduced, I leave it the way it is. For y to the power of 12, take half of the power I have, y to the power of 6. Square root of y cannot be reduced, I leave it the way it is. Then don't forget there's a negative sign in the front. Don't forget negative sign in the front. For the final answer, multiply number outside square root together. We have x to the power 3, y to the power 6. And don't forget negative sign. Negative x to the power 3, y to the power 6. Under square root is x times y. Under square root is x times y. That's the final answer. Next. Negative square root of 50 x to the power a, y to the power of 5. Negative 50 x, negative square root of 50 x to the power a, y to the power of 5. So when there's a negative sign in the front, don't worry about this negative sign. Take care of this sign later. Simplify the number under square root first. Simplify the number under square root first. Under square root, we have square root of 50, square root of s to the power 8, square root of y to the power of 5. Simplify each part individually. Square root of 50. 50 is not perfect square. It can be rewritten as 25 times 2. 25 is a perfect square factor for 50. Square root of 50 is square root of 50 times square root of 2. Square root of 50 is square root of 25 times square root of 2. Square root of 25 is 5. Square root of 2 cannot be reduced. I leave it the way it is. Square root of x to the power of a. When the power is even, take half of the power. When the power is even, take half of the power. When the power is odd, take we want, make it even. For y to the power of 5, when the power is odd, take we want, make it even. Square root of y to the power of 4, take half of the power. 4 divided by 2 is 2. And we leave square root of y in the way it is. Don't forget negative sign in the front. For the final answer, multiply the number outside square root together. Multiply the number outside square root together. We have negative 5. We have negative 5. X to the power 4. Y squared. What's under square root is 2y. What's under square root is 2y. Next. Negative 3 square root of 60x y to the power a. Negative 3 times square root of 60x y to the power of a. So we first of all simplify the square root first. Don't worry about this number. Do this number. Take care of this number later. Separate the number and the letters. We have square root of 60, square root of x, square root of y to the power of a. Simplify square root of 60 first. Let's try to find a perfect square factor for 60. For number 60, only 4 is a perfect square factor. 4 is a perfect square factor for 60. That's the only perfect square factor for 60. And 60 divided by 4 is 15. That means 60 is 4 times 15. 60 can be noted as 4 times 15. Square root of 4 is 2. Square root of 15 cannot be reduced. I leave it the way it is. Square root of x, that cannot be reduced. I leave it the way it is. Square root of x cannot be reduced. Square root of y to the power of a, the power is even. I can take half of the power. I get y to the power of 4. Y to the power of a, the power is even. For y raised to even power, I can take half of the power. So half of a is 4. A divided by 2 is 4. And don't forget negative 3 in the front. Don't forget negative 3 in front of the square root. Bring it down. For the final answer, multiply the number outside square root together. Outside square root, we have negative 3 times 2, which is negative 6. And also we have y to the power of 4. That's the number outside square root. Under square root, we have square root of 15 times x. That's the final answer. Next. Square root of 32 y to the power 16 z to the power of 10. Square root of 36 y to the power 16 z to the power of 10. So first of all, we separate the numbers and the letters. Square root of 36, square root of y to the power 16, square root of z to the power of 10. Simplify each part individually. Square root of 36 is 6. Square root of y to the power 16. When the power is even, take half of the power. When we take square root for y raised to even power, take half of the power. 16 divided by 2 is 8. Z to the power 10. When the power is even, under square root, when the power is even, take half of the power. Z to the power 5. And the final answer is 6y to the power 8, z to the power of 5. Next. Negative square root of 32. X to the power of 9, y to the power of 13. Negative 32, y to the power x to the power of 9, y to the power of 13. So we first of all separate the numbers and letters first. Don't worry about this negative sign. Take care of this sign later. We have square root of 32 x to the power 9 y to the power of 13. Simplify each part individually. For number 32, let's try to find a perfect square factor for 32. For 32, a perfect square factor could be 16 times 2. 16 times 2 is 16 is a perfect square. 16 times 2 is 32. Square root of 16 is 4. We can simplify square root of 2, so leave it the way it is. Square root of x to the power 8, x to the power 9. When the power is odd, take away 1, make it even. Take away 1, make it even. Square root of x to the power 8. When the power is even, take half of the power. We get x to the power 4. 8 divided by 2 is 4. Square root of x cannot be reduced. I leave it the way it is. For y to the power of 13, take away 1, make it even. Take away 1, make it even. Square root of y squared. When the power is even, take half of the power. We get y to the power of 6. Square root of y cannot be reduced. I leave it the way it is. For the final answer, multiply a number outside square root together. Don't forget negative sign. Don't forget negative sign. For the final answer, multiply the number outside square root together. We have negative 4 x to the power of 4 y to the power of 6. And also, multiply the number under square root together. Under square root we have 2xy. That's the final answer. Next. Negative 3 square root of 28 x to the power 9 y to the power 12 z to the power 15. Negative 3 square root of 28 x to the power 9 y to the power 12 z to the power 15. So first of all, don't worry about negative 3, leave it the way it is. Don't worry about the number outside square root, leave it the way it is. Simplify what's under square root first. Don't worry about what's outside square root. Simplify what's under square root first. So under square root, we separate the number and the letters. Square root of 28, x to the power 9, y to the power 12, z to the power 15. Simplify each part individually. Simplify square root of 28 first. 28 is no perfect square. Let's try to find a perfect square factor for 28. For 28, a perfect square factor is 4. 4 times 7 is 28. And 4 is a perfect square. Square root of 4 is 2. Square root of 7 cannot be simplified. We leave it the way it is. X to the power 9. When the power is odd, take away 1, make it even. Take away 1, make it even. Square root of x to the power 8. Take half of the power. When the power is even, we can take half of the power. That's x to the power of 4. Square root of x cannot be reduced. We leave it the way it is. Square root of y to the power of 12. When the power is even, we can take half of the power. That's y to the power of 6. For y to the power of 12 under square root. If the power is even, we can take half of the power. 12 divided by 2 is 6. Now, last part, z to the power of 15. When the power is odd, take away 1, make it even. When the power is odd, take away 1, make it even. Square root of z to the power of 14. When the power is even under square root, take half of the power. 14 divided by 2 is 7. And square root of z cannot be reduced. And leave it the way it is. For the final answer, multiply everything outside square root together and everything under square root together. Don't forget negative 3 in the front. Don't forget negative 3 in the front. Don't forget this number, negative 3 in the front. For the final answer, negative 3 times 2 is negative 6. And outside square root, we have x to the power 4, y to the power 6, g to the power of 7. X to the power 4, y to the power 6, g to the power of 7. Under square root, we have 7x g. Under square root, we have 7xg. That's the final answer.